Okay, so this is the last section of our chapter, and what we're going to do is we're going to talk about inverse trig functions, and sometimes you're going to see this, it's always like a capital letter, so like sine inverse, or you might see like arc sine, something like that. So depending on the book or the content, this is predominantly what you're going to see. But what we're going to be doing with inverses is we're going to be finding angles. What we've been doing so far has been finding points. So real quick, we're going to talk about this graph and use this graph to talk about inverses. So what's going to happen is, let's say I gave you 1/2, okay? Between 0 and 360 degrees. So I'm only looking at this portion. So before, I'd give you an angle measurement and you'd give me a point. We plot the points. So for example, I'd give you 1, or I give you 90 degrees and you get 1 for sine. This is a sine graph. So now what I'd like for you to do is look at this. What angle is going to give us 1/2 for sine? Okay. Well, notice here we have 2 points of intersection. And because of the idea of reference angles and the unit circle, which we've already talked about, and this is just the unraveling of the unit circle, we have certain values that repeat. And we're going to have, in a lot of our answers, we're going to have 2 different answers because of, hey, there's 2 values that are going to be the same. So this is 30 degrees and this is 150 degrees. Okay, so this is a little bit of memory, sometimes drawn pictures, but what I want to do is, if I told you guys to do sine of 30 degrees, you know, there's a couple little tricks that we can work with, knowing the unit circle. One of the things that, excuse me, we would do, probably one of the biggest things would be, let's draw a 30, 60, 90, right? So this guy is 2, this is 1, and this is √3. Well, what's sine of this triangle? It's opposite over hypotenuse, which is 1/2. If I did sine of 150 degrees, that's 150 degrees. So my reference angle is 30. Well, that's 1, 2, and negative √3, but sine, that's going to equal 1/2. So notice there's 2 values for 1/2, 2 angle measurements that give me 1/2. So what we're really going to do now is we're going to take and we're going to draw these pictures and we're going to work backwards to get these 2 angle measurements. And that's the basic idea of what's happening. Here's our first example. We want to find all possible values of sine of x is equal to √3 over 2. So because the variable is where our angle measurement is, that tells me I'm finding an angle measurement. This is also the other thing. These should have little degree symbols. So sine inverse of √3 over 2 is how we would write it, is equal to x. And so notice what I do is I make it an inverse function and I just switch the spot of the variable and the number. And this is just more notation than anything else. So √3 over 2. So what triangle is a √3 over 2? It's a 30, 60, 90. So I identify the triangle. Then I think to myself, what quadrants would I draw my triangle in? Well, my quadrants are based on whether sine is positive or negative. So I have to think in terms of all students take calculus. Now, all the stuff we've done from each section to each section is starting to come through in just one problem. Okay, well, I know sine is positive in the first and second quadrants. So that's where I draw my triangles. 2, and it's opposite over hypotenuse. So the opposite is √3, and I'm going to have the same triangle here. 2, √3, 1. Okay, well, what angle is always across from 30? 60 degrees. we have this rotation. If the reference angle is 60 degrees here, that makes this 120 degrees. So I have my two angle measurements. My first quadrant angle, 60 degrees, and my second quadrant angle is 120 degrees. And those are my two answers. I'll do a couple more examples, go through this, but the basic idea is identify the quadrants based on whether the sine value or the trig value is positive or negative. Draw your triangles, and then work backwards to find the angles. If it's not a special angle, you got to use your calculator.